Hello everyone, welcome back to the Network Fixer, your one-stop destination for mastering networking concepts, troubleshooting, design, and real-world IT scenarios. Today, we are diving into one of the most fundamental yet most misunderstood topics in networking, DNS or the domain name system. Whether you are a beginner trying to understand why DNS exists or an experienced network engineer dealing with DNS outages at 2 a.m., this video will give you everything from basics to advanced troubleshooting. By the end of this masterclass, you will understand exactly how DNS works, how to fix DNS issues like a pro, and how enterprises handle complex DNS environments. Let's start with the basics. DNS is the phone book of the internet. It translates human-friendly names like google.com into IP addresses like 142.250.195.78. But why do we need DNS? Because humans remember names, not IPs. Imagine remembering 5,000 websites in numbers. Impossible, right? DNS makes the internet usable. Example, you type gmail.com, DNS resolves, IP returned, and browser connects. You type facebook.com, DNS resolves, IP returned, browser connects. You type youtube.com, DNS finds the closest edge server, connects to Google infrastructure. DNS is a full ecosystem. Let's understand every actor involved. The first one would be DNS client or the resolver, your laptop, phone, or server that sends DNS queries. DNS resolver or recursive server, usually your ISP DNS, Google DNS such as 8.8.8.8 or internal DNS. Root servers, there are 13 logical root servers worldwide, A to M. These know where top-level domain servers are located. TLD or top-level domain servers. Top-level domain servers handle domain extensions like .com, .org, .in, .pk, .net. Authoritative DNS server, the source of truth for the domain. It stores all DNS records, A record, CNAME record, MX record, TXT record, NS record, etc. Let me walk you through the exact step-by-step process when you type a domain. You type www.youtube.com, browser goes with the OS cache and goes with the DNS resolver. Resolver checks its cache. If not found, queries root. Root redirects to .com top-level domain. Top-level domain points to authoritative DNS. Authoritative sends the final IP, example 11.13.55.121. Resolver caches it. Browser connects to the IP. Imagine 4 buildings, root, top-level domain, authoritative, your resolver. The resolver runs up and down the chain until it gets the answer. DNS has many record types. Let's break down the most important ones. Here are a few of the common DNS records. A record, it maps hostname to IPv4. A 4 times A maps hostname to IPv6. CNAME, alias name to another name. MX is for mail routing. TXT is for SPF DKIM verification. NS points to name servers. PTR is used for reverse DNS. SOA, zone authority information. For example, a CNAME for mail.domain.com might point to google.com if you are using Gmail. Next topic, DNS zones. There are a few zone types. Primary zone, which is editable. Secondary zone is read-only. Stub zone contains NS records only. Reverse lookup zone used for IP to hostname. Forward lookup zone, example facebook.com resolves to 10.15.25.35. Public DNS, example Google 8.8.8.8, Cloudflare 1.1.1.1, ISP DNS, authoritative for public internet. When it comes to private DNS, enterprise internal DNS, AD integrated DNS, handles internal host names and servers. Example, host1.thenetworkfixer.local, test.internal.abc.com. There are a few common attacks when it comes to DNS. DNS spoofing, DNS cache poisoning, DNS hijacking, DDoS attacks on DNS, security improvements, DNS security, DNS filtering, conditional forwarders, split horizon DNS, DNS over HTTPS or DOH, DNS over TLS or DOT. How do big companies like Microsoft, Amazon, and banks use DNS? When it comes to enterprise concepts, they use Active Directory integrated DNS, multi-site DNS, Geo DNS for global traffic, load balancing using DNS, failover using DNS Made Easy or Cloudflare, reverse lookups for security tools. Example include your organization using internal DNS for VPN users, external DNS for public websites, cloud DNS for Azure or AWS resources. A few useful tools in the DNS troubleshooting would include nslookup, dig, host command, ping, traceroute or traceRT. Common troubleshooting scenarios include DNS not resolving, check local DNS settings, check whether DNS server is used, ipconfig/all, test 8.8.8.8 versus internal DNS, website taking too long to load. It may be due to TTL issues, cache holds old IP, CDN resolution delay. If you're facing email issues, it may be due to wrong MX, SPF misconfigured, text format errors, VPN users can't access internal servers, split DNS misconfiguration, DNS suffix missing. If you open up your command prompt in the Windows laptop and type nslookup space google.com, you would see the IP address configured for the domain google.com. And likewise, if you execute the command ipconfig /flush DNS, it flushes the DNS. ipconfig /display DNS would display the DNS. So dig is the favorite command for Linux. If you're using Linux, you can use the commands dig google.com, dig at 8.8.8.8 microsoft.com. There are a few scenarios in the real life DNS. The first one might be DNS propagation delay. Consider you updated DNS, but some people see the old site. It may be due to the TTL not expired or resolver caching. Scenario 2, domain not resolving on some ISPs. ISP caches slowly, propagation pending, TTL set to days instead of minutes. Next scenario would be Outlook Auto Discover not working. This may be due to missing SRV record, incorrect CNAME for Auto Discover. The next scenario would be firewall blocking DNS. This may be due to DNS inspection, DNS rewrite issues. Thank you so much for staying until the end of this DNS deep dive. If you're watching this you are already ahead of most network engineers. DNS is one of those technologies that seems simple on the surface, but the moment it breaks, the entire organization feels the impact. If you enjoyed this masterclass, hit like, share, and subscribe. This is Mithun from the Network Fixer, signing off. See you in the next episode. Until then, take care of yourself and have a nice day. Bye bye.